power of heat. Heat is a form of energy, and despite the puny tolerance of heat by life on Earth, there seems no limit to the height temperatures soar in the universe beyond. Cold is altogether different. At 0 Celsius, water freezes. At absolute zero, it can get no colder, and that's far, far colder than the coldest place on Earth. In the field of low-temperature physics, this is how Nobel laureates explore the science of supercool. The speed at which atoms move is a measure of temperature. This solid is warm because its atoms are vibrating. The colder the temperature, the less they move. At absolute zero, minus 273.2 degrees Celsius, the atoms would stand still. This air is so cold it's turned liquid. In contact with other substances, it'll cool them by drawing out heat. Let liquid air evaporate and it'll liquefy hydrogen. And liquid hydrogen will liquefy helium, cooled to less than 5 degrees above absolute zero. A Dutch physicist is the first to liquefy helium. Heikki Kamerlingh Onnes wins the Nobel Prize for Physics. Liquid helium at minus 269 degrees Celsius, boiling in a flask. If vapor is continuously pumped away, the liquid helium will get even colder. It'll drop to within 1 degree of absolute zero. When using this process, the British physicist John Frank Allen discovers liquid helium becomes a superfluid. Independently, Russian-born Peter Kapitsa makes the same discovery and wins the Nobel Prize in Physics. Liquid helium goes superfluid at minus 271 Celsius. With its atoms barely moving, they no longer interact with each other. It's now a single energy state, heat spreading instantaneously throughout. Evidence of boiling subsides. For explaining the weird and wonderful behavior of liquid helium as a superfluid, the Russian Lev Davidovich Landau wins the Nobel Prize in Physics. All viscosity disappears in a superfluid. It flows through the tiniest hole, and it spurts like a fountain when a tube is inserted.